What the heck are one and two-tailed tests, and when do you choose them? Stay tuned. Sometimes when you're doing a statistical analysis, you'll be asked to choose between a one-tailed and two-tailed test. In a nutshell, this comes down to the question you're asking. Most of the time, we use two-tailed tests, but in some cases, a one-tailed test might be warranted. But what the heck does that mean? Well, in my video on how to do a one-sample t-test, I described my cousin's bagel bakery business, where she wanted to see if oldies radio listeners consumed more bagels than the average person, suggesting that advertising on the oldies station would be a good source of bagel-hungry customers. We set up our hypotheses such that the null was that the mean bagel consumption, or mu, of oldies listeners equals the mu of the population. In other words, they're the same. The alternative is that the mu of oldies is not equal to the mu of the population. Since not equals could be higher or lower, that meant that when we looked at our sampling distribution, we needed to look for statistically significant results in both tails or ends of the distribution, whether much higher or much lower bagel consumption. Any value above 1.96 or below negative 1.96 would be considered significant. This is because 95% of the data falls between these two values in a normal distribution. Only 2.5% falls above, and 2.5% falls below negative 1.96. For a total of 5% chance of making a type 1 error or false positive, which is what we said is acceptable to us. However, if we think about it, does my cousin really need to know if oldies listeners consume significantly fewer bagels? After all, my cousin's only interested in substantial bagel eaters. If oldies listeners don't eat more than the average person, then she doesn't care how many they eat. She isn't going to waste any money advertising there. In this case, an argument could be made that we only need a one-tailed test, a test that assumes the direction of the results. The null hypothesis in that case would be that the mean number of bagels eaten, mu, of oldies radio listeners, is less than or equal to the bagels eaten in the general population. The alternative is that mu of oldies listeners is greater than the population. Again, only one of these can be true, but we only care about results in the positive direction. Now, when we go back to our sampling distribution, we don't need that bottom tail. Instead of taking 2.5% from the bottom, we can take 5% just from the right side and still be right 95% of the time. We've kept our error rate constant. That lowers our critical value threshold from 1.96 to becoming 1.65, making the test more sensitive. In other words, more likely to detect a difference that's there. And we didn't change our overall error rate. So more sensitive test, that sounds good. Why not do this all the time? Well, in short, because it can be tricky to argue that you're justified in ignoring a significant result in the other direction. In science, we're frequently trying to learn information without bringing our pre-existing biases, or at least trying to reduce them as much as possible. And often, if we had surprising results that went against our hypotheses, that would be critical for us to identify. If you have a significant result in the opposite direction than you predicted, that would be a new problem to discuss and explore. For the vast majority of cases, you're going to want to stick with two-tailed tests, unless you're confident that you can justify why you are using a one-tailed test when you're challenged about it. In summary, two-tailed tests are the norm and don't make any assumptions about the direction of the difference observed. One-tailed tests, on the other hand, can be more sensitive, but are often hard to justify. So when in doubt, use a two-tailed test. I've got more videos on the way about basic inferential statistics, so stick around on this channel to get the scoop. Until next time, keep thinking. Hey, you know what's fun? Pushing buttons. So why don't you push the like button, subscribe, leave a comment, help us grow our channel so we can get the word out and help as many people as possible. Thanks.